In this video, we're going to be talking about the history of the periodic table and the different scientists that helped to contribute to its creation and the modern periodic table that we know now. We will also be talking about the periodic table and how it is set up and our different aspects of it. Now, the first periodic table came in 1790. It was really just a list of different elements that was compiled. There were only 23 elements known at that time. In 1870, there are around 70 known elements. So in just a span of about 80 years, we had quite a few different elements really discovered and experimented with that we were able to put onto that list. Now, 70 is going to be the majority of the elements on the periodic table. Currently, there is 118 elements on the periodic table that we know of. The first person to really come into the idea of a periodic table is going to be John Newland. He arranged the elements by atomic mass, and he called them periodic. Now, whenever he did arrange the elements by atomic mass, he did notice similar properties and arranged those properties into rows, which are going to be very similar to the columns that we know today. John Newland was really the pioneer behind the idea of the periodic table and really created the foundation for the other scientists we're about to talk about. Dmitry Mendeleev, he took the rows from Newland's table and put them into columns. But what he really did was that he left room for unknown elements that had not been discovered. So he really predicted unknown elements and assumed that these elements existed, even having no proof of that. And one of the big examples for that is going to be gallium. So he predicted everything that gallium was going to exist, even not having any proof of it. He just was reading the periodic table and noticed a pattern and assumed that gallium would exist somewhere. Now, not all the elements fit because he organized it based off of mass. As we should know, the current periodic table is built off of the number of protons in an atom or the atomic number. Now, one of the big kind of myths with Dmitry Mendeleev was that he was a card player, and on a train ride to a competition for solitaire, he put the elements on the back of playing cards and he arranged them that way. And so just kind of this idea of making it a game and arranging it very similar in a card style really helped build that idea of a repetitive pattern with the elements and their properties. Next came Henry Moseley. He organized his table by atomic number, which resulted in a very clear periodic pattern. And he is the father of our modern periodic table that we still use today. Now, he was able to come up with the idea of the periodic table because of a lot of other scientists that we already kind of know about, including Niels Bohr, Rutherford. So those scientists came up with the idea of like the protons in the atom, and Henry Moseley took that to the next level of organizing those elements based off of their number of protons. Now, Henry Moseley, his interesting fact was that he was in the British Army whenever World War I broke out, and he really went into the idea of serving his country, and he was unfortunately killed in Turkey due to an unfortunate bullet. But if he hadn't been killed serving his country, he probably would have won the Nobel Prize in Physics in 1916 for his work in chemistry. Now, all these different scientists that came up with the periodic table came up with the idea of periodic law. So when atoms are arranged in order of atomic number, they're going to present a very clear and repetitive predictive pattern that we're able to use and take advantage of. So by creating this very organized structure, we are able to predict what is going to happen with our elements. So just a little bit about the periodic table. So we do have our columns. Now our columns are going to be really important to us. So just remembering that our columns are going to be going up and down on the periodic table. So our columns are also going to be known as groups. All right, so we have group 1, group 2, group 3, group 4, and so forth. Now, remembering that group 1, these all have one valence electron. So everything in group 1 is going to be very chemically similar because they all have one valence electron. Same kind of idea if we are in group 13 or group 3. These have three valence electrons to them. So everything in this group is going to act very similar because of the number of valence electrons that they have. Next is going to be our rows. Our rows are going to be also known as our energy levels, or these are also going to be known as our periods that we're going to have. And our rows are going to be going from left to right. So these are going to go across the periodic table. Now, each of our groups do have a specific name to them. So our group 1 metals, so our alkali metals, these are going to be our group 1. And these are going to be located right here. Again, these all have one valence electron, and so that means that their reactivity is going to be very, very high. So because they have one valence electron, reactivity will be high. Next is going to come the alkaline earth metals. These are going to be found in group 2. These are going to be these ones right here. Now, our group 2 metals have two valence electrons, so their reactivity is still going to be high, but only a little bit. So these and everything are going to be a little high as far as the reactivity goes. So it's still high, but not as high as the alkali metals from group 1. The next group that we're going to talk about are going to be the transition metals. So these transition metals are going to be this middle block right here. So these are all going to be considered to be transition metals. So this is going to be group 3 through 12, and their reactivity will be low. So our transition metals are very stable. They're not going to react with a lot of different things. And that can be seen in a lot of the metals that we use for construction. So iron, titanium, those are all very stable metals that we are able to use for building because they don't react with other things. The next group that we're going to talk about is going to be the halogens. These are going to be group 17. These are going to be these ones right here. So our fluorine, chlorine, bromine, iodine, so forth. Their reactivity is going to be very high. So these and everything are going to have a similar reactivity to group 1 metals. They only need one valence electron in order to become stable. So they're going to want to do that in order to get to that octet that they want. And then the last group that we really need to know about are going to be the noble gases. These are going to be in group 18. These are going to be on the far right side. These all have 8 valence electrons, with the exception of helium, which only has 2 valence electrons. Now, the noble gases do not react, so their reactivity is low to non existent. So, this is very, very low. So, very, very low reactivity for the noble gases. In a way and everything to kind of help remember that is that think of the idea of nobility, especially in medieval times. So the nobility does not really want to interact with the commoners. So the nobility is going to want to just stay by themselves. So the noble gases do not react with other things. And that is going to be a quick overview of the periodic table and the history. Let's go ahead and talk about the properties of metals. So, metals will typically have a very high melting point. They are going to be really good conductors. And so, what that means that they can conduct heat or they can conduct electricity. This is why the majority of our wires that we use for charging electronics are made out of copper. Copper is extremely good at conducting electricity and it has a really high melting point as well, so it's less likely to catch on fire or to melt while it is carrying that electrical charge in order to power our devices. Metals will also typically have a high density to them. They are going to be malleable, which means that they are able to be shaped into different things. So if we hammer a piece of metal, we are able to get what we want from it. And they are also ductile, which means that we're able to draw them out into a wire. Some properties of the metalloids: these will have a metallic luster to them. They are typically going to be brittle and they are semiconductive. And so, what semiconductive means is that they are somewhat conductive, but not extremely good conductors themselves. And so, what semiconductors are made out of is going to be our electronics. So, silicon is going to be a really big metalloid that we use pretty much every single day. Those are going to be like the motherboards that power our laptops, tablets, phones, anything that has essentially a screen to it is going to be made out of a metalloid. All right, and then we have our nonmetals. These will typically have a low melting point. They are also going to be brittle, and most of them are going to be a gas at room temperature. So our nonmetals are going to be on the right side of the periodic table. So we are going to include a lot of those noble gases with this, oxygen being a nonmetal. So a lot of those nonmetals are going to be a gas at room temperature.